Let's move on to example 2. Example 2 asks us to graph a cube root function. Okay, so this is very similar to what we talked about in example 1 and our group warm-up, except in this case we're dealing with a cube root function. So in this case they want us to graph y is equal to -3 times the cube root of x, then state its domain and range. So right off the bat I'm dealing with cube root, so I know that when I start plugging in values for x, I want nice numbers like perfect cubes that we can get nice numbers back out. If you remember our perfect cubes, I'll make a list over here on the right. 0 cubed obviously is 0. 1 cubed is obviously 1. 2 cubed is 8. 3 cubed is 27, and the list kind of continues on. But this list right here on the right is what our perfect cubes are, very similar to perfect squares. So I want to pick nice numbers that I can plug into the cube root of x and get nice numbers back out, very much like I did for example 1. I also want to point out that my index for the cube root is 3, which is an odd number. So if it's an odd index, remember back to our previous lessons, I'm allowed to have negative numbers inside my radical symbol. So my radical can also be negative numbers here. Unlike example 1 where I have even index, which is 2 for square root, I can't plug in negative numbers for that case. So in example 2, I want to pick nice numbers that I can plug into this equation. So nice numbers, positive and negative, I'm going to pick these type of numbers here, the positive forms of them and the negative forms of them to plug into my equation. So on the left hand side I'm going to pick -8, -1, 0, and then I'm going to pick these same values back out but in the positive form. And those are the numbers I'm going to be plugging into my equation to get values out for y so I can plot them on my graph. So if I plug them in, -3 times the cube root of -8. Well, the cube root, if I take the cube root of 8, I know I get 2, so the cube root of -8 gives me -2. And -2 times -3 gives me a +6. Same thing here, -3 times the cube root of -1. Well, the cube root of 1 is 1, so the cube root of -1 is going to be -1. -1 times -3 gives me a +3. -3 times the cube root of 0. Cube root of 0 is 0. 0 times -3 is still 0. -3 times the cube root of 1. The cube root of 1 is 1. 1 times -3 is -3. And -3 times the cube root of 8, well, the cube root of 8 is 2. 2 times -3 is -6. If I take these values and plot it over on my right-hand side, -8, 6 is my first ordered pair, so -8, 1, 2, 3, 4, 5, 6, 7, 8. I'm 6 units up, 1, 2, 3, 4, 5, 6. I have an ordered pair there. -1, +3 gives me an ordered pair there. 0, 0 is my origin. 1, -3 gives me an ordered pair here. And 8, 1, 2, 3, 4, 5, 6, 7, 8, 6 down, 1, 2, 3, 4, 5, 6 gives me an ordered pair right there. If I connect my curves, or my points with the curves, I get the cube root graph. It looks just like that. If you notice, because I have a negative leading exponent here, my graph is going to be the flip version of my original. So instead of going from quadrant 3 to quadrant 1, I'm actually going from quadrant 2 to quadrant 4. So they flip over that y equals x line, or they flip for the negative. So they actually, not y equals x, but it flips over my x-axis. So this becomes, so what was in quadrant, so I just lightly dot it. That was my original. So if I flip over my x and flip over my x again, I have the negative form of my cube root function. My domain in this case, because my graph spans all my x's, negative, positive, and 0, my domain is all reals, and my range spans my positive y, 0, and negative y, so my range is also all reals for example 2. At this point, I want you to take some time to work on the Now You Tries numbers 1 and 2, and we'll come back in the next video to talk about the graphs of radical functions.